Hi, freshmen. I hope your time here so far has been enjoyable. It'll only get harder from here on out, so to get through it, you need to be aware of how your mind works. You'll study better and make better decisions, but to do this, we need to be aware of our cognition and how it works. You might ask,
What the does that mean?
of Ms. Yang's 9th period, AP Psychology class.
well, I'm here to explain it to you. So, firstly, let's go over what you can expect here from Brooklyn Tech, or what you have been expecting. I'm sure you remember your first time walking through those doors. You saw the school online, it seemed great, wonderful even. Nice lobby, cool majors. Oh, by the way, the LAS major is the best major, objectively. Big school. This is how your brain categorizes things. It groups together things into an idea of what something should be like. So, combining all of these perfect ideas of this school, you come to develop this perfect image of tech in your mind. But then you walk through the doors, and as you go through your first few months of classes and come to where you are now, your image of tech is completely different. Filthy kids in your gym classes, broken elevators, actually, broken everything. Cafeteria food that tastes like the grime scraped off of an oil rig worker's glove. And those teachers that drive you insane. Not you though, Miss Yang. The perfect visualization of tech you had before you came here isn't gone though. It's just been updated, and this is the way your brain works. As you develop new information through your experiences, like learning that the school isn't all it's cracked up to be, your brain adapts and accommodates this new information and integrates it into your previous visualization of Brooklyn Tech. So now, all that you think about when you hear the name of this school mentioned is the annoying parts of it. So a small piece of advice we learned from our brain is to learn to expect the unexpected, to adjust when necessary, and most importantly, to learn from your past experiences. Hopefully you understand now that your brain's thinking process consists of adapting and creating associations between things, like how you, or at least I, compile all the bad things about tech and associate them with the school's name. Something interesting we do though is we create jumps in our thinking process. Firstly, heuristics. Heuristics are the fastest path to a conclusion your brain takes, and are quick but sometimes illogical paths to a final thought that are designed by your brain to save time. For example, you might pick a line in the cafeteria to stand in because it's shorter, even though that side has worse food. You're only standing in it because it's short, and you're not considering that it has worse food for you to eat. It's less thinking, so you get to a conclusion of what line you want to stand in faster, even if it's the wrong line you want to be standing in because you don't want to be eating terrible school food. Or you might have heard stories about a particular teacher from your upperclassmen friends and assumed that they're terrible without considering why they're saying that they're bad. In this instance, your brain is making decisions based off of the availability of the context in your head. And with the most readily available information, like the stories that your friends have told you, your brain sometimes makes decisions that are more uninformed than informed. For example, you don't know why this teacher is bad, you just know that they are bad because of the stories that your upperclassmen friends have told you. Another type of heuristic is judging things based off of how well they represent something. For example, you might see the partner I did this project with and think he's a nerd. But don't be so quick to judge things, because this is actually your brain playing into the pre-existing stereotypes that you hold, where you associate him with nerd-like representative traits, and associate how well he fits the nerd stereotype. In reality, he's a great guy, and not a nerd, even though he is a computer science major. In summary, our brain works off of past experiences and convenience, instead of real, comprehensive thoughts sometimes, so think things through before doing them. This is important to know so that A, you don't judge people, B, so you can make informed decisions about how you want to go about projects, tests, classwork, and so that just in general you can stay informed when you make decisions. Oh, and also, on a related note, since I have to cover all these terms, I hope you guys are aware of two mental fallacies, or illogical conclusions. Firstly, the gambler's fallacy, the idea that if an event hasn't occurred recently, it's more likely to occur in the future. Think of flipping a coin and getting heads or tails. If it's not heads, like 5 times in a row, you might think that it's more likely to be tails the next time you flip it, but it's not, because it's an independent action. So don't answer your multiple choice tests off the logic of, well, it hasn't been C in a while, so I'll pick C this time. And secondly, the next illogical fallacy is the sunk cost fallacy. The idea that, oh, well, I have to keep going with whatever I've been doing because I've spent too long on it. I'm saying this for academic reasons. It is relevant to you. Don't keep going with a project or a club that you don't enjoy anymore just because you've already put too much time into it. It's okay to let it go if it doesn't bring you value or happiness. And now, while we're talking about how your brain perceives the world, we need to talk about creativity. You might think, oh, I'm not that creative. No, everyone is creative. Creativity isn't so much about having zany, wacky ideas than it is approaching problems or tasks in new ways. For example, think about when you go home and you eat your dinner, and you want to watch something, but you don't have a phone holder. Have you ever used something as a phone holder while you watch YouTube, like a water bottle? That's creativity. Being able to see an intended, normal purpose for something, like a water bottle, you drink out of a water bottle, and changing it to suit another purpose, like turning it into your phone holder while you eat. This brings us to the opposite of creativeness, functional fixedness. This consists of only seeing an object for its intended purpose and nothing else. Nothing is a paperweight except a specifically built paperweight, and nothing is a phone holder except a phone holder you buy off Amazon. And while there's nothing wrong with seeing objects as being used for their intended purpose, it's important to keep your creativity so that you can go about your life in a smarter way. And on a related note, we operate off mental sets, which are the ways we've learned to do something. We have this notion of a correct way to do a project, or a correct way to work out, or whatever else. And while this does lead to routine, which is good, it also might limit us sometimes to what we think is the correct way of doing something. And this can cause disagreements, especially if the people around you think group projects have different correct approaches to topics that you approach in your correct way. So just keep an open mind. Lastly, this brings us to ways that your brain approaches problem solving. When faced with a problem, your brain either narrows down all of your thoughts into one single correct solution, or your brain fires off a million different ideas and picks a solution from one of those. And this is actually crucial for brainstorming for projects. What you should be doing is you should be using both of these. You should be firing off a million different ideas to brainstorm, and then you should narrow those topics down to a single correct idea. Don't just come up with the first random idea that pops into your head and use it for your project. You're getting a bad grade because you're not planning out your topic well enough.
We now understand how our brain perceives the world, but how do we store the information that we perceive? Let's talk about memory. As presented in my elaborate diagram here, we see that our memory works in 3 stages: encoding, storage, and retrieval. I hope these terms are somewhat self-explanatory, but if they aren't, that's what this guidebook's for. Firstly, we start off with encoding. This is when your brain receives information from the outside world and sends it to your storage, basically encoding it into your brain's internal repository. There are a lot of ways to encode information, and some are better than others. Let's start off with the thing you encode automatically. You don't need to make a conscious effort to remember the face of your friend or the walk to your home. However, there's some things you have to put effort into encoding. I wish I could encode everything into my brain automatically, but as is clear by my transcript, I can't. Now, when you have to put effort into encoding something, you can either process it on a shallow level or a deep level. Shallow processing is just like reading over the terms of your exam without really understanding them. You might remember a bit, but it won't stick for long. On the other hand, deep processing involves actually understanding the meaning behind what you're learning, which makes it more likely to be stored as a long-term memory. This is where things get interesting and useful. When you understand the material, you can remember it more easily. For example, instead of memorizing terms as just words, try to relate them to your own experiences for what they mean in the real world. But I don't care, I hear you say. You should. Why? Encoding lets us study better. I'm sure you all love studying so much, but if you study well, you won't have to stay up until 3 a.m. the day of your finals. So here are some awesome psychology tips. Firstly, please sleep. Sleep is so important. I don't care if you learn a million new words by staying up. It doesn't matter if you don't sleep. The reason you sleep is so that your brain can consolidate all the things you've learned and encode them into your memory properly. If you don't sleep, you don't encode the things you've learned, so it doesn't matter. Not only will you be tired and miserable, you'll also have done all of your studying for nothing. So sleep. In terms of actual studying, the most important thing to remember is don't cram study. So many people have probably told you this before, but I'm going to explain why. According to the spacing effect, it's far easier to encode memories into your brain's internal storage if you do it slowly over time than if you cram it in all at once, since your brain has more time to encode things and inevitably will encode them better. But how do you study? The best ways are the ways that associate your memories to something, rather than mindlessly memorizing terms or information. Categorize the things you've learned into groups. For example, you might study things related to one unit one day, and things related to another unit another specific day. You can also use mnemonic devices. This one's really easy. It's basically just acronyms, images, songs, or other memory aids. Think PEMDAS. That's what mnemonic devices are. Lastly, the most interesting one. Study things in different specific locations. When you try to remember things, your brain will associate a topic with the location you studied in, and you'll remember it better. Next in the order is storage, or your brain's reserve of memories. Your brain stores memory in different ways. Let's go over it chronologically. First, your brain stores memory in sensory memory. It holds information for a very brief moment. For example, if you stare at the sun for a bit, you'll see the imprint for a brief time. Next, this memory is turned into long-term memory, which holds your information for a longer time. Long-term memory has a huge capacity for storage, but depends on if you actually keep it stored in your head. Let's put it into two types, explicit and implicit memory. Explicit memory is the stuff you voluntarily have to recall. Think concepts and facts you learn in school. Implicit memory is the stuff you remember automatically, like riding a bike or how to type on a keyboard. If you want to be even more specific, there's also episodic and semantic memory. Semantic is like general knowledge, and episodic is your memory of specific events. How is this important to you at all? Honestly, it isn't much more important than the things I've already said. Repeat things to remember them better, use episodic memory to your advantage, tie information to your life, and think about how the concepts you've learned apply to you. But anyway, you still need to know how your memory storage works to understand the most important part of this guidebook, which is... If you're tired of our video for some reason and want to leave this class, fear not, this is the last part, naturally because it's the most important. Your brain needs to recall this information to use it effectively. There are a lot of factors that affect this recall. Here, I'll teach you how to understand and control it. Firstly, there are different methods of retrieving memories from your storage. You either recognize it and associate it with a memory, like noticing a familiar multiple choice question on a test, or you recall it without any cues, like a fill-in-the-blank question. Preferably, you should be able to recall things without the cues. But how? After you've memorized all the terms you need for a test, test yourself with a practice quiz instead of flashcards. Studies show that testing yourself is one of the best ways to solidify your memory and understanding of topics. Make sure you're in the best possible mental state to take a test or do an assignment or whatever other situation you need to recall your memories in. Your retrieval of memories is affected by what mood, bodily state, and context you're in. For example, if you're at a party having fun, you'll remember things related to partying or happy memories. If you're miserable, you'll recall different memories related to being miserable. You can see how this can apply to tests. Be in the best bodily state you can whenever you need to recall information. You forget information really quickly right after you learn it, but if you manage to encode it into your long-term memory, it's very hard to forget. Here's a graph to explain that. To combat the initial drop in retention, repeat your studying over and over. This is just a reiteration of my previous point of keep studying over time with a different justification. Don't listen to your stupid friend if you think they're wrong. Your brain can take misinformation and construct a fake interpretation of your memories from that added misinformation, warping the good memories you had into the wrong memories. And lastly, please sleep. Sleeping is important. I cannot reiterate this enough. Anyways, we've finally come to the end of the guidebook. The key takeaways are that you need to study over time and not cram, you need sleep, and you need to take care of yourself. Hope that if nothing else, you've taken away these few pieces of advice from this guidebook. Remember to study smart, make the right decisions, and never stop learning. The way you think, the way you approach problems, and the way you remember things will make all the difference. Good luck.